what we have to do is multiply by the conjugate, which is what? What is the conjugate, Caitlin? Negative 3, wait, what did you say? It's the sign in the middle is the opposite. That's what cancels inside. So negative 3 minus radical 5. Okay. All right, then we distribute the numerator. So we get negative 21 minus 7 square roots of 5. Okay, which we see there. Now, do I have to FOIL the denominator? We have to FOIL it? No, we just multiply the first and the last. So we have negative 3 times negative 3, which is 9. Plus and the minus would be minus. Square root of 5 times square root of 5 is 5. And 9 minus 5 is 4. Okay, go and stop it there. Now, if you look in the directions, it says identify any excluded values. Now, the only excluded value is the value that would make the denominator equal to 0. So they're asking you, is there any values for x that would make this undefined if you substituted it in? And that's 8, because 8 times 7 would be 56, and you cannot have it. So the first thing I write is x cannot equal 8. Okay? Now, in simplifying, we look for common factors. Is there a common factor in the numerator? This is what we got to remember. We've got to remember to factor. I think, got to remember what to factor. What's the common factor in the numerator? 5. So we take out a 5. So we take that out, and inside we have x minus 8. What's the common factor in the denominator? Now I'm going to do a negative 7. Just so that I have positive x inside the parentheses. Negative 7 times negative 8 would give me that. And then this would be plus x. Now, are those two the same? They are the same, okay? So if they're the same, then you can cancel them out. And so we're just left with negative 5 over 7. Okay? Remember to factor. Remember to factor, simplify. I think that's where most of you are messing up. Caitlin, you good? All right, keep rolling with it. Okay, now, the cubed roots are pretty easy. What's the cubed root of 27? What times itself 3 times? Yes? 3. So these two are both equal to 3. Okay? So this is 45. 3 times 4 is 12. Now, square root of 27, what you have to do with that is break it down. Prime factor. So look at this. If you don't remember the easy way, you could, is there a perfect square that goes into 27? 9 actually, right? So you could write square root of 9, square root of 3, simplify that way. But this rule always works. Break down this. So 27 is equal to 3 times 3 times 3. So you've got this, we'd write square root of 3 times square root of 3 times square root of 3. Okay, do the same thing here. Square root of 3 times square root of 3 times square root of 3. Okay, that's square root of 27. It's equal to those 3 all, yes ma'am?
Why didn't you just do 3 in front?
We are. I'm just really breaking it down for you, okay? Then radical 3 times radical 3 is 3, and 3 times 7 is 21. So this would be plus 21 square root of 3. This would be 3 times 3 minus 9 radical 3. Then we just add like terms. 45 plus 12 is 57. 21 square roots of 3 minus 9 square roots of 3 is 12 square roots of 3. And we're done. That's not done. Okay, you've got 3 spots. Taking 3 at a time, that's what it means. That's what I would put, 3 boxes. How many choices do you have in the first? If you've got 8 things. 8, but now you've used one. So then you have 7, and then you have 6. And now I multiply those together, and I'll get my number. Okay. All right, number 8, we want to see that one. All right, first of all, we gotta make sure that's in descending order, and it is. Oh, actually, no. I thought it was gonna be simple. This takes a little bit more work. Yes, sir.
How to use?
You personally, for this problem? Or how about you just take a picture of it? Would that be okay?
Yeah.
All right. Okay, now this one's actually easier than the one we just had on the previous test. Okay, there's not another term added to it. So you just got to, just like division, take your first term, 14x cubed divided by 7x is what?
2x squared.
Is what? 2x squared. Okay, and then we multiply it, which we get 14x cubed, and then we do what? Yeah. We change the sign or we subtract it. We only have one term, so it's easy. We don't have to. Okay, if we subtract it, it goes away. Bring down the next one. Negative 7x squared divided by 7x is what?
Minus x.
Minus x. A negative x times 7x squared. Okay, if we multiply it, we get negative 7x squared. We subtract or change the sign, well, that's just going to cancel that out. Okay, 7x goes into 9x how many times?
1.
Only goes once, doesn't go in evenly. So we do that. 1. I should have lined this up over top so that it lined up and I ran out of room there. See this? That should be, it's still going to work out. It's just a little off. Okay, so we subtract 7x, we get
2x.
2x. We bring
Plus
down the 4. Okay, that will be my remainder. So my remainder, just like you would write a normal remainder, you write this in the numerator, divided by that 7x. That's what you have left over. Okay, plus that. You get a picture? I just draw a line that would best fit it. Yes?
Is this gonna like a packet?
That's exactly what I want, just like that. Okay. All right, so you got more time. Keep rolling with the video. It's crazy that this works out this way, but actually 15 and 17, do you notice that they're, both of those equations are the same line? If you look at the first one on 15, 4x plus 3y equals negative 5 is just twice, or it's half of the second equation. And then as well on number 17, if you were to multiply the top equation by 3, you would get the same exact answer. So they're the same line, so there's an infinite amount of solutions. Did you all see that? Why they have 2 of them. Now, saying that, probably one of them I will give you that will not be that case. So you'll need to solve it by substitution. We good with how to solve by substitution? No? Okay. Let me show 17 then. Okay, in substitution, the first step is to get one of the variables by itself. Now the nice thing about this one is y is already by itself. Yes?
Is there a way we can do one that doesn't have y already? Because that happens to me every time.
No, it'll be like this, so don't worry, okay? Y is equal to x minus 5, meaning I can replace y with x minus 5 since they're the same, since they're equal. So I do that. and then we work the equation out. Now when I do that and I distribute, we notice we get 3x minus 15 is equal to 3x minus 15, showing that they're the same line. And if they're the same line, how many points do they share in common? An infinite amount. Doesn't necessarily have to be that way on the test, but if it does come in there, there's an infinite amount. It's not no solution, but an infinite amount since they're the same line. Yes, sir.
What I did was I already had the 3x over, so it's like negative 3x, and then the x is canceled out, and then it's negative 15 is negative 15. It's like the same thing.
Did you do it? What process did you use? Did you use elimination? Okay, say it again.
I did.
Let me just, you can stop. Number 16, determine whether those are solutions of the system of linear inequalities. All you're doing is testing those points to see if they work in both. Okay, substituting those in. So I'm going to substitute 5, 2 into both, see if they work for both. What if they work for one? What's my answer if it only works for one? Is it a solution if it only works for one? No. It's only a solution if the point works for both of them. Okay, so you substitute all those points in. All right, any other ones? Before we go, we've got a few minutes left. We know how to do 19. Divide and then evaluate. That's another one where we got to cancel the factors. Yeah, absolutely. All right. Okay, now it's division. I want to make it into a multiplication problem. How do I do that?
You switch the
First or second one, good. Okay, change it into a multiplication, so this becomes 7xy cubed over 12x cubed. Now I can cancel any common factors in the numerator and denominator, wherever they are. 7's cancel, right? You've got an x here and an x there, that would cancel. 24 and 12 have a common factor, so that would reduce to 2.